All right, this is section 4.1. This is video number 2 that I'm going to go through. In that first video, we talked about how to describe the transformations from that vertex form and what vertex form looks like. And if you remember, it looks a lot like your absolute value graph that we've done early in the first semester. So it's not going to be a lot different. It'll be a little bit different when we're graphing these. But in this video, we're going to go through and graph these. And just a couple reminders. Now that I've got this up here, you can cross out all of these steps down here. Just cross them out. We're not going to follow these steps in graphing these. I've got a little easier and different method that we're going to use to graph them. Just a couple reminders. Again, to find the vertex, remember it's the opposite of H, okay? And the letter K, opposite HK, that's the vertex. You're always going to plot that point first, just like normal. No different than you would with your absolute value graph. The axis of symmetry, same as the absolute value graph, x equals h. So whatever h is, that's what your axis of symmetry is going to be. It's the line x equals h. And then to determine if it's a maximum or a minimum, okay, on the maximum, it's always going to be facing down. The maximum point is going to always be at the highest point. That's why we call it a maximum. It's got a high point. And that's always going to be at whatever the vertex is. Same with a minimum. On a minimum, the parabola is facing up, and you see this is the minimum value. That's the lowest value that it will be. It would be right there. And again, that maximum or minimum will always be at the vertex. Okay, so now let's take a look over here. And this part you don't have, so you want to jot this down. This is really important. And these are what we call the graphing shortcuts to graphing different types of equations. Okay. And eventually I'll get you a sheet of these, but for right now you can write these guys down. So if you want to pause it, I'm going to keep going, but if you want to pause it and write these down, we are talking today specifically about graphing quadratics. So this is what you're looking for right here in how we're going to graph these. So how do we graph a quadratic function? Well, first thing we're going to do is we're going to graph h and k. That's essentially we graph the vertex. It's no different than absolute value. Now this is how it's different than absolute value. Before we would always treat a like slope. Well, we don't treat a like slope in these equations, in these problems, because this is not a straight line. Okay, these are curves. So as we're looking at this, what you're going to do is you're going to go graph the vertex, and then you're always going to go right one, and then either up or down, depending on whether a is positive or negative. You're going to go up if a is positive, down if it's negative, and it's 1 times a. So for example, let's say a was 1. You would graph the vertex. You would go right 1 and up 1, because 1 times 1 is 1. Then you would go from that next dot that you just created, you would go right 1 and up 3 times 1, which would be 3. And then if there's room, you would go right 1 and you would go up 5 times 1, which would be 5. Now, a lot of times, guys, this number 4, you're probably not going to have room to fit that in there. Sometimes you will, a lot of times you won't. Okay, then same thing as our absolute value graph. Once you've done that, then you're just going to reflect those points across, because this thing is symmetric. So the right side and the left side are exactly the same. Okay, now that you got those down, let's go ahead and let's look at some of these examples, and let's go through a couple examples to graph them. All right, so on your homework, what I'm going to have you do is you're going to graph these, and then you're going to describe for me the transformations, tell me what the axis of symmetry is, the domain and the range, and tell me if it has a maximum or minimum and where it's at. Now, the one thing that's going to be on your homework as well that you will not have to do is the x-intercept and the y-intercept. For right now, we're not going to do that part of it, okay? But all I want you to be able to do is tell me the transformations. In other words, how did this thing move? Be able to find the axis of symmetry. Be able to tell me what the domain is, how far left, how far right it goes, what the range is, how low, how high it goes, and then tell me, does this thing have a maximum or a minimum value, and if so, where at? Okay, let's dive into the first example. Y equals x squared. Okay, so first thing we've got to figure out, all right, what is the vertex? So as we look at this thing, I need to know what are h and k. Well, if you remember, this is our general vertex form of a parabola or of a quadratic. And you'll notice we don't see any parentheses, and we don't see a number after the x squared. So what does that tell us? Well, just like the absolute value, that tells us our vertex is the ordered pair 0 and 0. Okay, so what I'm going to do is I'm going to go and I'm going to plot the ordered pair 0, 0. 0, 0, right smack dab in the middle, right there. Okay, now my graphing shortcut sheet. As you look at this equation again, my A value is 1, my H is 0, and my K is 0. Okay, so when I go to graph this thing now, I start at my vertex, and it tells me after I plot my vertex, I'm going to go right 1, and I'm going to either go up or down. Well, how do I determine if it's up or down? My A value is positive, so I'm going to go up. So in this case, I'm going to go up 1, or excuse me, right 1, and then I'm going to go up 1 times A. Well, in this case, A is 1, so 1 times 1 is 1. So what I'm going to do is I'm going to go right 1, and I'm going to go up 1, put a dot, like so. Then I'm going to go right 1 and up 3 times A. A is 1, so I'm going to go right 1, up 3. From that dot that I just made, right 1, and I'm going to go up 3. And then if I have room, which I do in this case, I'm going to go right 1, and I'm going to go up 5 spots. Just like so. Okay? So now I'm going to reflect it, so they have to go to the other side. Same thing, I'm going to go left 1, up 1. I'm going to go left 1, up 3, and then I'm going to go left 1 and up 5. And now you have your very first parabola curve. And it's going to follow just like so. And just like so. That's really bad, but you guys get the point. Okay, now, so let's describe some transformations here now. Okay, first, let's do axis of symmetry. Well, I know my axis of symmetry is the line x equals h. Well, what is h in this case? H is 0, so the axis of symmetry is the line x equals 0. If you remember, we used to draw the blue line on there, so like I would do this on my graphs, where I would go right through the vertex like so. Okay, you can do that if you want to help yourself out. Okay, that's the axis of symmetry, is that blue line right there. All right, transformations. How does this thing shift? Well, this thing is the parent function. So what do I mean by parent function? It's the original, most basic parabola. So in this case, there are no transformations. There's none. Okay, it's not moving at all. It didn't go right, didn't go left, didn't go down, didn't go up. It's not stretching, it's not compressing, none of that. Okay, all right, so domain. How far left does this thing go? Well, I see this arrow right here as I'm following through. How far left does it go? That arrow, that means it's still going over here. That means it's going all the way to negative infinity. And again, if I follow the right side, there it goes. It's still going way up here to the right. Well, what number is that? That is at positive infinity. Now comes the challenge, the range. How low does it go? Well, as I follow this thing, it comes down to 0. And then what does it do? Well, it goes back up. So the low point is at 0. So on the range, the lowest point is, I'm going to put a bracket here because it goes to 0 and it stops. And then how high does it go? I have both those arrows, which means it goes to positive infinity. Okay, does this thing have a maximum value or does this thing have a minimum value? Well, it has a minimum value. So it has a minimum value because it has a low point. It's facing up. Okay, it has a low point. And where's that minimum value at? That minimum value is at the vertex, which is the ordered pairs 0 and 0. Okay, so that's the very first graphing of a parabola. It's the easiest one you're going to do. Okay, let's take a look here at the second one. Now, our numbers are going to change a little bit as you look at the equation. Okay, my vertex is going to be the ordered pair. In this case, I don't have an h because there's no parentheses, so that's a 0. And my k is negative 5. What's my a value? My a value, what's the number in front of x squared? That's 1. Okay, my h is 0. And my k value is negative 5. Okay, so now I'm going to, again, plot the vertex first. Okay, so I go to plot the vertex there at 0, 0. I'm going to go right 1, and then in this case, A is positive, so I'm going to go up 1. So I'm going to go right 1, up 1, because it's right 1, up 1 times A is 1. Then I'm going to go right 1, up 3. Then I'm going to go right 1 and up 5. And whoops, I screwed this up. Let's do this again. It's not at 0, 0. Where's my vertex at? My vertex is at 0, negative 5, not 0, 0. So let's start that over again. And then from there, we're going to go right 1, up 1. Then we're going to go right 1, up 3. And then I'm going to go right 1 and up 5. And then I'm going to reflect this guy. Just like so. Okay, now we can draw our parabola. All the way up through, put the arrows up. Okay, and now we can describe. All right, transformations. How did this thing move from that last graph? Well, this guy right here tells me something. That number, that tells me, in this case, this guy shifted down 5. That's a K value. So the transformations was down 5. That's it. There's no H and there's no A values. What's the axis of symmetry? Well, my H is 0, so it's X equals the ordered pair, or the number 0. Remember that line, that blue line we could put in there. And then the domain. How far left, how far right does it go? Well, it's negative infinity to positive infinity, left to right. And then the range. How low does it go? Well, it goes to this spot right here, which is negative 5 in this case. And it goes to positive infinity. Maximum or a minimum? It's got a minimum in this case. It's got a low point, so that minimum is at the ordered pair 0 and negative 5, which happens to be the vertex. Okay, let's take a look at one more example here, and then I'll let you get to going on your practice problems. I'll be a little bit more extensive here on this one. So, in this case right here, let's see here. Let's find the vertex first. In this case, the vertex is, remember, it's the opposite of this number and then this number. So, in this case, it's negative 4 and, negative 2. Negative 4, negative 2. Okay, so our vertex is the ordered pair negative 4, negative 2. My A value this time is 3. That's going to change some things on our problem. Okay, so I know A is 3, I know H is negative 4, and I know K is negative 2. All right, so let's graph this thing. So negative 4, negative 2, that's my vertex. So I'm going to go left 4. I'm going to go down to, put a dot. Left 4, down 2. Now, it tells me on my graphing shortcut sheet that I'm going to go right 1, and I'm going to go up 1 times A. Well, in this case, A is 3. Well, 1 times 3 is 3. So I'm going to go right 1 and up 3, not right 1, up 1. Then I'm going to go right 1 and up 3 times 3, which happens to be 9. So right 1 and up 9. And now on this one, I go 5 times A, that's 15. I'm not going to have room for 15, so in this one I'm only going to have 5 dots. And I reflect, like so. And now we can zoom in here and draw our parabola. Notice this one is a lot narrower, it's a lot skinnier. We come down. Okay. All right, so let's go transformations. How does this thing move? Well, first, we know that it's moving, in this case, left 4. We know it's moving down 2. That's my H and my K. We also know that this thing is being stretched What's the number that gave that away? Well, that was my a value. A value is bigger than 1. Okay. What's the axis of symmetry? Well, it's the line x equals h, and in this case, h is -4, so x equals -4. What's the domain? Again, left to right, negative infinity to positive infinity. How far left and how far right it goes. What's the range? How low does it go? Well, in this case, it goes down to -2, and it goes all the way to positive infinity. Maximum or a minimum? Again, this one, since it's facing up, has a minimum value, and that minimum value is at the ordered pair -4, -2. Okay, it's always at that vertex. All right, now you should be able to complete your practice 4.1a problems on Schoology. Make sure you take care of that. Again, you do not have to find the x-intercept and the y-intercept on your problems.